Thank you for joining this lesson. We're going to discuss quadratic graphs. Number 7 in this paper. We are told that we complete the table below for the equation y equals to x squared minus 4x plus 2 for 2 marks. So we got a table here, x and y. We're going to fill the table by inserting the correct values of y which correspond to the given values of x. Now to do this, we are already given the values of x and the function relating y and x. So for us to get y, we need to square the values of x, then negative 4 multiplied by the value of x plus 2. For instance, the first value of y is going to be given by, according to the equation, we need to square the value of x, so 0 squared minus 4 into 0 squared, not really squared, plus 2, which is a constant. So this becomes 0, this becomes 0, then plus 2, the constant. So the first value is going to be 2. In the next value, we got 1. So we insert 1 in the values as the value of x. So y is going to be, we got 1 squared minus 4 into 1 plus 2. So this becomes 1 minus 4 plus 2. And this will give us a negative 1. So we'll have a negative 1. We insert the value as 2, and we're going to get negative 2, then negative 1 at 3. Then from there we get a 2. Then at 5 we will have a 7. So that is how the table is going to appear. The next thing is on the grid, draw the graph of y equals to x squared minus 4x plus 2 for the values of x ranging between 0 and positive 5. Therefore, I already got an axis here, whereby we're going to draw the graph of y against x. Y against x. So we have the first value, 0, 2. So I'm going to start with 0, 2. This is the first coordinate. The next one is going to be 1, negative 1. So I plot 1 against negative 1. This is where the coordinate will lie. The next one is 2 against negative 2. So 2 against negative 2. 3 against negative 1. 4 against 2. And finally, we got 5 against 7. So that is how the plotted coordinates are going to appear. They are already suggesting a curve, because we can already see it's not a straight line, so it can only be a curve. Therefore, to draw the graph, I'm going to connect these plotted coordinates. So I'm going to join them with a smooth curve from this point up to the last. Remember, the curve should be smooth. Yes, so that is how the curve is going to appear. A smooth curve joining all the points. So this is the curve for the equation y equals to x squared minus 4x plus 2. So that is our curve already drawn. The next thing now is to use this curve to solve some given equations. So what we do when we're given a quadratic equation to solve using the graph, we usually take the plotted equation then we subtract the given equation from this drawn equation. All the terms should be aligning. This is negative 4 plus 2. So when we subtract every corresponding term, y becomes y because we're subtracting y and 0. But x minus x becomes 0. 4x minus 4x becomes 0. 2 minus 2 also becomes 0. This is negative 4x minus negative 4, which means negative 4 plus 4. It also becomes a 0. So everything becomes 0. So we need the line y equals to 0. And where this line cuts the graph, then we'll get the roots for this equation. This is the x-axis. So we will see where the x-axis is cutting the given graph. So we're going to have the point 0.6, because it is this point, 0.6, and also 3.4, just before 3.5. So we got 0.6 and 3.4. So the values are going to be 0.6 and x is also equal to 3.4. We go to the next equation, which is going to be solved. X squared minus 5x plus 3 equals to 0. So we take again the original equation and we subtract the given equation here. 0 equals to x squared minus 5x plus 3. So y minus 0, this gives us y equals to x minus x squared, that becomes 0. Negative 4 minus negative 5, it becomes negative 4x plus, because of the negative and another negative, plus 5x. That gives us x. Then x, we have 2 minus 3. This gives us a negative 1. So now we're going to operate with another line here, x minus 1 equals to y. So for us to get this line now, it is not drawn by default like the x-axis. We need to get a value of x and also y, and we get some few values of x and y, but within the range at which the graph has been drawn. So we can begin from 1, 2, 3, 4. I think these are enough. So we need, when x is 1, y is going to be 1 minus 1. This is 0. When x is 2, we subtract 1 to get y. When x is 3, we subtract 1 to get 2. When x is 4, we subtract 1 to get 3. So we're going to plot these values. I'm actually not going to plot all of them. So let me start with 1, 0. 1, 0 is going to be here. That is a coordinate. Again, we're going to have coordinate 2, 1. 2, 1. This is the coordinate. Again, I'm going to have 3, 2. That is the coordinate. I'm also going to have 4, 3. 4, 3. That is the coordinate. So now I should join the plotted coordinates to get the straight line. Yeah, this is my line. Use a different ink. So this is the straight line now, which is equal to y equals to x minus 1. Then now I'm going to use the intersection of the line and the graph to know the equation of the given curve. So where they are intersecting, like this point, I got to drop and read this value. So the value of x at the point of intersection is going to be x at this point equals to 4.3. Yeah, 4.3. Then I also check the other point of intersection, which is this one. The other point of intersection, and the value of x at this point is going to be also 1.3. Not 1.3, 0.7. Sorry, hatujafika 1. We are still before 1. So we're going to have 0.7 as the other point of intersection. So I'm going to have x as 0.7 and x as 4.3. So the values of x for this equation are going to be 0.7 and also x equals to 4.3. So that is how the graph is going to be. That is how the equations are supposed to be solved. Watch, subscribe, and share.